Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is split. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. We are given a binary string s, and what we do is we define a function over s as the longest non-decreasing subsequence of s. So for example, the function value of 0011 is equal to 4. All the four numbers are arranged in a non-descending subsequence. Similarly, function over the string 0101 is 3, because if we go over it, we have this subsequence that is the longest non-decreasing. Now similarly, once we are given this string s, what we have to do is, for the string of length n, we have also given an integer k, and our task is to split this into k substring. And this substring will be, let's say, t1, t2 till tk, and it should be in such a manner that once concatenated, they give us the s back. So you have a string s. What we do is we are breaking it so that we have k subsequences. Here k is equal to 4. Now, for this we define the score as the minimum value of function over all the values of t. So we have t1, t2 till tk, and for each of the ti, what we are going to do is we are going to get the function of this. Now for all the functions of this, the score is defined as the minimum value, and our task is to maximize this minimum value possible, or you could say that our task is to maximize the possible score. So for input format, we have t test cases, and for each test case we have two lines. The first line will contain two spaced integers n and k, n being the length of the string and k being the number of subsequence or substrings that we have to divide the string s into, and the second line will have the binary string s itself. So for the output, on a single line, we simply have to output the maximum possible score. As for the constraints, number of test cases will go from 1 to 10 raised to 4, value of k will be less than n, and the value of n will go from 1 to 2 into 10 raised to 5. And since s is a binary string, it will only contain the characters 0 and 1. Let's have a look at the example. So in the sample example, the first that we have is where the length of our string s is 5, and we have to divide it into two substrings, and the string given to us is 10110. Now let's say what we do is we will have to divide it in such a way that the minimum, remember what we are going to have is we are going to have a t1 string and a t2 string. The score is going to be the minimum of both of them. So our task is to increase the ceiling of this minimum value. So what we can do is to increase the ceiling of this minimum value, let's say we divide it from here. This is our T1 and this is our T2. So if you go over this, the maximum subsequence of non-decreasing is of just length 1, because if you choose 1, there's nothing else to choose. And if you go to this T2, here the maximum length is 2. So if you see what is the minimum is 1. Now what we can do is we can try to see whether we can increase this minimum. So let's say rather than dividing it here, we divide somewhere here. So here we have divided now. Now here the subsequence is of length 2, but here again the subsequence is of only length 1. And if we go any further, the string itself will be of length 1. So the minimum that we could get, even if we try to maximize it, is just 1. Therefore, the answer is also 1. Similarly, we can check for all the other strings. Let's see how we can approach the solution. So in this case, once we have the string s and we have the string k, we know that we have to divide them into t1, t2 till tk. So while we are dividing this, what we are trying to do is we are trying to maximize the value of non-decreasing subsequence in the t1 or ti. So what we can do is we can try a binary search here. We will run the binary search on the minimum one. So think of in this manner. Let's say we say the score x. So now what we can try to do is we can keep on going until we hit a mark where we have reached the length of x as the longest subsequence. So something like this. We have the string. We keep on going until the subsequence length is of x. If it's at x, what we are going to do is we are going to say that this is one division. This is our t1. Again, we start. we can follow until we hit the value of x. That is, again, this is now t2. So with this, what we are going to do is we are going to keep on making these substrings. Now, if this count of substrings is greater than or equal to k, this is fine with us. Why? Because what we can do is, if there are way too much, if it is greater than k, we can simply merge some of them and make it the exact value of k. But what we are making sure is that every small bit, every ti has the subsequence that is that is equal to x. So with this, what will happen is, if you take the minimum, it will be x. So what we can do is, over the value of 1 and n, we can do a binary search. We can check whether the middle value, is it possible that that every every substring has a subsequence length greater than this mid value. If yes, if the answer is yes, what we can do is, we can then try to search it in the right portion. We again do a mid, then we check what is the answer. Similarly, by performing the binary search, we can find what is the max value of this x that we can get. And once we get this, we'll make sure that all the ti's or t1, t2 till tk that we have formed will have a subsequence length greater than x. Therefore, whatever a minimum you choose, it will be equal to or greater than or equal to x. So with this, what we'll do is, we'll suffice the condition that is to maximize the score. And with this, we have our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and k and then the binary string s itself. Then for the binary search, we initialize our lower bound as 1 and the higher bound or the upper bound as n. And our initial answer is 1. Then what we do is, we find the middle, and for this middle we check whether it is possible to make sure that all of our substrings has the exact subsequence length of this mid. So for the binary search, what we are doing is, we are going over the string. We first count. If we encounter 1, we increment the count of 1. If we encounter 0, we increment the count of 0. Then, since we want to find the longest subsequence, what we are going to do is, for 1, we'll take whichever is maximum. Because once we have encountered 1, we cannot take 0, right? We'll have to take 1. But that is not the case with 0. If we encounter any zeros, it is possible to take further ones. So for 1, it will always be between maximum of 1 or 0. Next up, at each point we'll check whether the maximum subsequence length that we have reached till now is equal to mid. Because if it is equal to mid, what we're going to do is, we're going to break it and say that this is one of our ti. Next up, we will make zeros and ones and they will again start the count. With this, what we are going to do is, we are going to do subsequences, or we are going to find substrings who have the subsequence length of k, of non-decreasing length. Then once we have this, at the end we have a count. This is the count of substrings that we can form, where each substring has a non-decreasing of size mid. Now if this is greater than or equal to k, this is good for us because we can reduce this to k and make sure that even the smallest one has the length of mid. So once we do this, we run our binary search and find what is the maximum width that we can go till. At the end we print it, and as you can see, I've got an AC in my C++ implementation. Let's see how we can do this in Python. Again, for each test case, we call the function solve, take the input of n, k and string s. Once we have this, we run our binary search. For each mid, we check whether it is possible to have equal to or more than k substrings such that each substring has a non-decreasing subsequence of length mid. Once we do this, we find the maximum mid and this will be our result. As we print it, you can see that I have got an EC in my Python implementation. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I will see you in the next video.